Howdy, howdy, this is Mr. Potter. There's been a lot of discussion on the internet about YouTube's algorithm for determining whether or not a video gets monetized. In other words, what makes YouTube decide that your video is worthy of a green dollar sign or is worthy of the yellow dollar sign? And in order to understand YouTube's algorithm, we really need to understand the concept of machine learning. And in order to understand machine learning, I like to start with an example I call BOGO sort. When I teach computer science, I teach different ways of sorting. And one of the ways that I discuss in sorting is a very ineffective and unreasonable way of sorting is the notion of BOGO sort. In other words, if I have some random assortment of numbers, and I want to sort these numbers, one of the ways that I could do is imagine I take these numbers and I throw them up in the air. And then I pick them up and I put them in the order that they fell. So I could have a 2 and a 4 and a 1 and a 6 and a 5 and a 3. And then I ask myself, is that sorted, yes or no? If it is sorted, then I'm done. If I'm not sorted, then I've got to do it again. And I'm going to throw these up in the air and I'm going to get some random assortment of numbers. And I'm going to have to ask myself, is it sorted again, yes or no? And eventually, through sheer luck or just sheer amount of time, one time I'm going to throw it up and I'm going to get 1, 2, 3, 4, 5, 6. And when I ask myself, is this sorted, yes or no, I'm going to say yes. In other words, by sheer random coincidence, I can end up in a situation where my numbers end up completely sorted. And machine learning is very similar. Machine learning basically takes a program and says that it wants to teach it something. For example, teach it the difference between 3's and e's. And so I'm going to have a computer that's going to randomly throw together stuff. And it's going to tell me something like there's that this is a 3 and this is an e and this is an e and this is a 3. And then I'm going to go completely randomize it again. And then it's going to tell me, okay, now this is an E, and this is a 3, and this is a 3. In other words, it knows that these should all be 3's, but it's not always going to tell me that. Eventually, though, if I have tens of thousands of computers running simultaneously, I'm going to find that one machine that hits this by random 100% of the time, and hits this 100% of the time. In other words, it's not necessarily going to know what a 3 is or what an E is, but it's going to have some notion of distinguishing between a 3 and an E. Some notion that for this set of test data that I've got here on the screen, answers it 100% correctly, 100% of the time. And then I'm going to take this computer that's working 100% correct for these data, I'm going to give it some different data. And then it's going to have to tell me whether or not these are E's and these are 3's. And it has a notion of E-ness and it has a notion of 3-ness that it's developed from its data set. These are the things that it knows. But it's having to make a choice based on what it's learned so far. And maybe it decides that this is a 3 and this is an E and this is a 3 and this is an E. And we're going to have to go back to the drawing board. Or we're going to have to make slight tweaks, just little bare tweaks to this algorithm. Say, no, this is an E. Learn that this is an E. Put this E in your E data set. Similarly, this is a 3. So put this 3 in your data set. And eventually what happens is, through generations and generations of computers, now keep in mind these generations may only last 10 or 15 seconds. But after we go through this cycle of teaching a computer, testing a computer, teaching a computer, testing a computer, eventually it's going to get pretty good. And it's going to tell me that these are all correctly an E or a 3 depending on the situation. The issue comes when I give it something that's not so clear cut. So for example, this letter right here, is it an E or is it a 3? Because our computer only knows how to figure out if something is a 3 or an E. It has no concept of there being anything else. And so what it's going to do is it's going to say, it's got nice straight lines like an E does. It's blue. Most of my E's were blue. This is definitely an E. And it's going to tell me with pretty high confidence, based on what it's learned from the data sets, whether or not it's an E. Now, this is the way that machine learning works. And what happens is, because we've got machines determining at random, I may have at Google or at Amazon or at Apple, I may have tens of thousands of virtual machines. And some of these virtual machines are going to be very good, and some are going to be bad. The only way I can tell is through testing. And through testing, I'm going to eliminate the bad ones. And I'm going to propagate the good ones. In other words, these good ones, I'm going to make a copy of, make a slight tweak in the program here, a slight tweak in the program here, a slight tweak in the program here, and then I'm going to test it again. And through each generation, I'm going to get programs that are better and better and better at telling the difference between a 3 and an E. Now, of course, when I'm dealing with letters and numbers, it's pretty simple. There's some pretty basic characteristics. But what about if I wanted to figure out a difference between a dog and a cat? Now, again, this notion of just throwing things randomly in the air, starting out with random, and ending up with something that's good with this data set. In other words, it can get every one of these cats. It can say, hey, these are all cats. And it can get every one of these dogs and say, these are dogs. But then again, we run into the situation of, okay, fine. Is this a cat or a dog? And of course, depending on the algorithm, it could say, well, it's brown, and most of these dogs up here were brown, so it's clearly got to be a dog. Or notice how all of these cats have these ears like this, and this animal has these ears like this. It's clearly a cat. And this is the thing about machine learning, is that it's only going to be able to yay or nay. It's only going to be able to yes or no. And it's going to put something into a category based on its own notion of what it's learned from its test data that came completely at random. So, what happens when you get a YouTube video and you want to get well, I don't want a golden dollar sign, but what's going to happen is the algorithm's going to look and say, we've got a beard here. A beard is untrustworthy, so we're going to vote that down. Or it's going to say, exclamation points. Exclamation points are good, so we're going to vote that up. Or it's going to look at this and saying, okay, the title doesn't match the text in here. We're going to vote that down. Or it's going to decide this is not the correct shade of gray. We're going to vote that down. Or I see a forehead up here, and foreheads means the person is knowledgeable, so we're going to vote that up. What actual aspects that the machine learning is looking at, we have no idea, because it's been determined completely at random. And that's why it seems completely at random that certain videos get the thumbs up or the thumbs down. However, there are some things that it notices very well. It may notice, for a fact, if something looks like clickbait. And those things that look like clickbait get voted down a lot more. And that's how the machine algorithm learns. So what we need to look at then is, okay, then what do we do to improve this? Well, this is where you have the challenge system. This is where you get to look at YouTube and say, hey, YouTube, I'm going to fill out this little checkbox and say, hey, my video is appropriate. And YouTube is going to tell the machine operator, the machine, it's going to tell this computer, yes, this was a good video and you're a bad program for not recognizing it. And my video is going to be put into the next generation, making slight tweaks to this program so that it does get propagated into the YouTube system as an appropriate video. This is how machine learning works. This is how YouTube decides whether or not you get that golden dollar sign. This is how YouTube decides whether or not a particular video is trending. And it's just something that we have to get used to. So once again, this is Mr. Potter. Thank you for watching. Have a great day.